Welcome to another session of Ebenezer Gate coaching classes. This is a problem that appeared in one of the Gate question papers. It's a numerical aptitude type problem for 2 marks. The open loop transfer function of a unity feedback control system is given by g of s is k by s into s plus 2 for the peak overshoot of the closed loop system to a unit step input to be 10%. The value of k is dash. Now let us derive the peak overshoot for a second order system. The transfer function of a second order system can be written as T of s is equal to omega n squared by s squared plus 2 zeta omega n s plus omega n squared. Now for a unit step input, the Laplace transform of a unit step input is 1 by s. So the output will be T of s times 1 by s. Output will be 1 by s times omega n squared by s squared plus 2 zeta omega n s plus omega n squared. Now, if you have to find out what is y of t, you'll have to do partial fraction expansion. If you expand it in partial fractions, you will get y of s is 1 by s minus s plus 2 zeta omega n divided by s squared plus 2 zeta omega n s plus omega n squared. Now if you further expand it, you get y of s as 1 by s minus, you can split s plus 2 zeta omega n as s plus zeta omega n plus zeta omega n divided by, denominator can be written as s plus zeta omega n the whole squared, which is s squared plus 2 zeta omega n s, which is already there, and we'll have an additional term zeta squared omega n squared. So you'll have to subtract that term and you get omega n squared minus omega n squared zeta squared. Now this is written as 1 by s. I make it as two terms. One is s plus zeta omega n by s plus zeta omega n the whole squared plus omega n squared. I take as common and write it as 1 by zeta 1 minus zeta squared. Then again minus zeta omega n divided by s plus zeta omega n the whole squared plus omega n squared into 1 minus zeta squared. Let omega d, which is the damped frequency, as omega n times root of 1 minus zeta squared. So I get y of s is 1 by s minus s plus zeta omega n by s plus theta omega n the whole squared plus omega d squared minus theta omega n. I divide and multiply by omega d into omega d by s plus theta omega n the whole squared plus omega d squared. We know that inverse Laplace transform of s by s square plus a squared is cos at, and a by s square plus a squared is sin at. So this term will translate into, if you take inverse Laplace transform, you will get sin omega dt, and since you have replaced s by s plus sigma omega n, theta omega n, you will have the inverse Laplace transform will be multiplied by a term e power minus theta omega nt, because whenever you replace s by s plus a, inverse Laplace transform will be multiplied by e power minus at. So when I take the inverse Laplace transform, y of t is 1 by s is 1, and this is e power minus sigma omega nt cos omega dt minus theta omega n. I am writing this as omega n root of 1 minus theta squared, that is omega d, and this is sin omega d. Let root of 1 minus theta squared be sin theta, and zeta be cos theta, implies theta is tan inverse of root of 1 minus zeta squared by zeta. So y of t is 1 minus e power minus, I'm taking root of 1 minus zeta squared outside. Inside you'll have root of 1 minus zeta squared cos omega dt plus theta sin omega dt. Already I know zeta is cos theta and root of 1 minus zeta squared is sin theta. So this can be written as 1 minus e power minus omega nt by root of 1 minus zeta squared sin theta cos omega dt plus cos theta sin omega dt. So y of t is equal to 1 minus e power minus zeta omega nt by root of 1 minus zeta squared Sin A cos B plus cos A sin B is sin of A plus B. The sin of omega dt plus theta. When omega dt is equal to pi, we get the peak overshoot. So let us find out what is the peak overshoot. That when omega dt is equal to pi, what happens? 1 minus e power minus omega n. T is pi by omega d. Omega d is again omega n root of 1 minus zeta squared by root of 1 minus zeta squared sine of pi plus theta. We know sine pi plus theta is equal to minus sine theta, and sine theta already we know is root of 1 minus theta squared. So y of t will become 1, since it is minus root of 1 minus zeta squared, minus into minus will be plus e power minus pi theta pi root of 1 minus zeta squared by root of 1 minus zeta squared into root of 1 minus zeta squared. So these two terms will get cancelled and you will get 1 plus e power minus pi zeta by root of 1 minus zeta squared. So the peak overshoot is the term above 1, that is e power minus pi theta by root of 1 minus zeta squared. And we are told that peak overshoot is 10%. So peak overshoot, so this is 10% or it is 0.1. That means e power minus pi theta by root of 1 minus zeta squared is equal to 0.1. So taking logarithm, natural logarithm on both sides, is equal to ln of 0.1. So ln of 0.1 is minus 2.3. So minus pi z zeta by root of 1 minus zeta squared is equal to minus 2.3. So squaring both sides, you get pi squared zeta squared Let me write it here. This implies pi squared zeta squared equal to 2.3 squared. 2.3 squared is 5.3 times 1 minus zeta squared. If you solve this, you will get zeta is equal to 0.59. And what is the equation that is given? Equation g of s is equal to k by s into s plus 2. For a unity feedback system, it will be g of s by 1 plus g of s will be t of s, the transfer function. So this is k by s into s plus 2 divided by 1 plus k by s into s plus 2. So this is k divided by s into s plus 2 plus k. So this is k by s square plus 2s plus k. So if you compare this with the original equation, then you get 2 zeta omega n is equal to 2, or zeta omega n is equal to 1, or omega n equal to 1 by zeta, and k is equal to omega n squared, or equal to 1 by zeta squared. You already found out zeta as 0.59. So 1 by zeta squared is 1 by 0.59 whole square, which is 2.86. So the answer to the problem is, the value of k is 2.86. The value of k is 2.86. Thank you. God bless you.